It's time to learn a new programming language as we learn about databases. Database management systems are important, heavily used, and interesting pieces of software that record and retrieve data and serve as the primary data storage for most software applications. They organize their information in tables, which are collections of records, which are rows in the table that have a value for each column in the table. So for example, you could have a table with 3 records, one for Berkeley, one for Cambridge, one for Minneapolis, and 3 columns, the latitude, longitude, and name. A table has columns and rows. A column has a name. It also has a type. So all of these are strings, all of these are numbers, and all of these are numbers. But if you look across a row, there are values of different types. And a row is just a value for each column in the table. The structured query language, called SQL, or often SQL, is perhaps the most widely used programming language in the world. It's the language that you use in order to interact with a database. SQL is also a declarative programming language, and so it has different properties from the languages we've studied so far. In brief, declarative languages have programs, but that program is just a description of the desired result of the computation. Instead of describing how to compute it, you just describe what you want to compute, and it's up to the interpreter to figure out how to generate the result efficiently and effectively for you. So instead of spending a lot of time thinking about the process that's going to build the resulting data that you want, you just say what data you want, and it's up to the computer to figure out how to compute it for you or build it for you. Imperative languages like Python and Scheme are different. They have programs, but those are descriptions of computational processes, and the interpreter carries out the execution or evaluation rules for the processes that we describe. So we get to move now from describing the process of computing a result to just describing the result. Here's another table of cities. This one's a little different than the other one because it's got New York in it. Here is an example of SQL or SQL. This is called a query, and the role of a query is to take an existing table, like the cities table, and build another table, in this case one that has West Coast as one of the values in each row, along with the name of the city. And it doesn't include all the cities, only the ones where the longitude is large, meaning it's on the West Coast, and orders these cities by their latitude, from least to greatest. That would produce a table that looks like this. It has a region column because I asked for it. It has a name column because I included the name. The names come from this table, Los Angeles and Berkeley. West Coast actually comes from the query itself. And most importantly, the rows that it selected are not all of the rows in the cities table, but only the ones that have a large longitude. So just with this one example, you get a flavor for how SQL works. You don't have to say whether you want to sort by longitude and pick the first few, or iterate over the rows and append the rows with a high longitude to some list. You just say you want rows with high longitude, and it's up to the system to figure out whether to do that before it orders by latitude or afterwards, before it selects out the name or afterwards. All those details really aren't your problem. Your problem is just to describe the table you want it to build, and it will find a way to build it for you.